I'm going to be talking about classical composition in G with a sneak peek at something Zai's been working on that we're hoping to release to the community. So it's okay. I prepared for this because after every break, it's taken a couple minutes for everyone to like get back. So I have some like pending slides of nothing in particular, nothing that I spent a ton of time on that didn't get to actually compete.
But you're not there.
No, not at all. Anyway, you can tell that this is going to win. That's just ridiculous. And then I made a second slide, just, you know, for fun. Well, justice for anyone an Airbud fan? Remember Airbud? Yeah, there's no rule that says a dog can't play basketball, right? Yeah. People have been calling this the cheating square. I don't know what they're talking about. I like to think of it, like Norm says, as the insightful square. Okay, a little bit about me before we get started. My name is Mike Lay. I am with Zai Solutions. I'll talk about that in a moment. But I've been a LabVIEW user since 2006. I've been a CLA since 2011. Been running the San Diego LabVIEW user group off and on since 2014, so hopefully hit the 10-year mark next year. I think everyone has done this thing where they have like their LinkedIn version of themselves and then the real version of themselves. So you can see here, I like to rock climb, not very good at it. The mask might make you think this is COVID era, but actually the air quality in Bangkok is just atrocious for 3 months of the year. So I'm just like protecting my lunch from that. Oh, yeah, it was rough. If this were like a more inspirational presentation, there would be like a montage of me trying that again until I got it, but I never actually finished that one, so. So Zai Solutions, I like to say that we're a global phenomenon. We have Casey and Dan over in the Bay Area. I'm originally from San Diego. Adam was our guy over in the UK. And then I actually moved over to Asia. So we were hitting 3 continents for about a year. And then Adam, because he likes to ruin things, he moved back to New York City. But yeah, we're a group of CLAs. We have a shared particular interest and experience in developing large-scale applications. We pride ourselves on clean, modular, high-quality solutions, adhering to solid design principles, which I think everyone says that, so you'd have to look at our code to tell for sure. We have some packages you can download on BIPM if you're interested to see if we live up to our own hype. I would say together we have over 50 years of combined LabVIEW experience, so we've kind of touched a little bit of every industry from biotech, medical devices, automotive, aerospace, VR headsets, et cetera, semiconductors. This is our little contribution to our giants are female tradition at these LabVIEW conferences. This is Jessica Wade. She is a London-based physicist and researcher. She's a recipient of the British Empire Medal for her contributions to science, advocate for gender equality in STEM, and one thing she's noted for is writing more than 1,750 Wikipedia entries on previously unrecognized contributors to STEM who are women and minorities. And I think that it's important to highlight individuals like her who advocate and put in time to research and highlight these kinds of things, because especially as we enter this age, I think, of accelerating misinformation with technologies that can kind of make any claim they want. I think it's important that we appreciate this thing like a bullshit asymmetry principle, which is it takes about 10 times as much effort to correct misinformation than to produce it. And so people who are putting in that monumental effort, I think we should applaud. This is what we're going to go over today. I'm going to talk about inheritance really quickly. I saw it during Alan's last presentation that a lot of people already use classes, so I'm just going to blaze through that part. For those of you who use classes, how many use composition? Okay, about half the room. So I don't have to explain that too much. And if you're already super familiar, then hopefully at least you'll get some examples when people are asking you why you should use composition. Maybe you can point back to this presentation, point back to the video later, and be like, hey, these are some really good reasons that you might want to consider composition. I'm going to go through like a fairly straightforward Harvard communication example, and then I'm going to go into a slightly more involved, but I think still not too complicated example of driver and logging together, like a hardware driver and logging. And then I'm going to show you a sneak peek at moZart, which is something, again, we're working on at Zaya that we're hoping to release. That for me, the reason that we started writing it is because I love composition, but there's certain mechanical aspects of composition that I really do not enjoy. And moZart kind of eases that pain a bit. Okay, so what is inheritance? Well, it defines an is-a relationship, and parents can pass attributes onto their children. I know that Pokemon, these are not actually parents and children, right? It's like evolution, but the point remains that Raichu inherits Thunderbolt from Pikachu, but he can also extend that behavior with Hyper Beam. So, all right, no one's a Pokemon fan, that's fine. There's gonna be another slide later that'll probably be very confusing for people too. All right, a real world example. So you're in a lab, you're writing an application with a couple kinds of hardware, and you have like it's Agilent, a specific model, you have some force sensor of some other specific model, and you're writing the code, and you're finding that you're doing a lot of operations the same because they're both serial devices. And you find that you're doing all this port configuration, this opening and closing of connections, this reading and writing from the port. And you're like, oh, I have all this duplicated code. Why am I doing this? I'm a good programmer. I'm going to use that object-oriented stuff that everyone's always talking about. And I'm going to write a serial parent class. How many people have done something like this? Yeah. How many people still do that and think it's like this is like something you do regularly? I did this, for sure. Yeah. And I think in some situations it works. But it works for great reasons, right? Like all this serial code, it doesn't have to be duplicated across your classes. And you keep in the same place. If you have a bug in your serial communication, there's one place it's pointing to, great. That's all the great things about inheritance. If you need to add another serial device later, you just point to this class. You don't have to rewrite that code or copy it from anywhere. Awesome, right? Here's the wrench. Suddenly one of your end users is like, hey, I'm using the same Agilent, but I'm going to be talking to it. Right, so I'm saying like, yeah, so you can use the serial write to send specific commands for the Agilent. The serial base is defining the communication, and then the Agilent is saying, hey, I'm going to send this specific ASCII command, right? All that's awesome. You've separated the responsibilities between the parent and child. But then when your end user is like, I want to communicate with Ethernet sometimes. And so what do you do here? Can you do this? Can you point from that class to that class? All right, you're going to mention interfaces, I think, yeah, so sort of. But that even with interfaces, I think you'd still have to copy code. You'd end up copying code, right? So that doesn't work. And why doesn't it work? Because this is what we want, right? We want to be able to just, say, hey, we have our concrete devices, and here we have this interface. We want to swap between these two different write methods. That's the only difference between the code, right? Ideally, we would dynamic dispatch somehow, but we really can't, right? We can't directly dynamic dispatch this way. And why? What's the fundamental limitation? And I would say the limitation is that in G, classes are like Disney protagonists. You're only allowed to have one parent. All right, thanks for the applause. That makes all the effort to make this animation totally worth it. So it's a fixed inheritance tree, right? What do we do? And I think that a lot of people, I did this early on when I was first introduced to OO. I had this problem, and something I did was I said, well, it sucks, but I don't want to like duplicate code. I'm gonna point to this Agilent Ethernet version class, and I'll have this Agilent serial class. Right? And depending on which one, I'm just going to choose one or the other. And that's like, it's not really what we want, right? Because we're saving ourselves from duplicating the communication interface, but kind of the more important code, I would argue, this details, this measure voltage stuff that the Agilent defines, that's being copied across these two branches of the inheritance tree. And that's not good. That like is it's completely against the philosophy of object-oriented encapsulation. The reason we move to classes is to avoid this kind of maintaining multiple code bases that are doing like 98% the same thing, right? So what do we do? And I think if you pay attention to what the presentation is about, you're probably going to know that the way we get to what we want, where we have the child class pointing to hardware implementation, and the communication details being defined by different child classes, different serial, Ethernet, USB, whatever. We can do that with composition. And what does that look like? So with composition, instead of pointing to a serial or USB or Ethernet, whatever class, parent class, we composite a communication class into the adjoint class. So you can see that over here in your private data, you've got communication class. I went ahead and made wrappers. So like, okay, so you would load, so at runtime, you can load which kind of communication interface you want. This could be configurable, whatever. And then you get that dynamic dispatch, right? Because inside your write class here, you're pointing to your communication class, your unbundling communication class, going to the dynamic dispatch that you want. And that's all very nice, right? That's a much better way to do it. You get exactly what we wanted in that previous slide. Any questions so far? All right, that was easy. So again, what is composition really quick? I think everyone knows. You define a has-a relationship between two or more classes. You allow the container class to contain behaviors from many different member classes. So with the Pokemon example, you can combine their powers and you just get much better, more adaptable code. Definitely not some horrifying abomination of science and man. Like, much better code if you do it right. Okay, here's another example. So let's look at a force sensor this time. I'm going to move away from, I have some actual code for this, so I'm going to move away from like the serial USB discussion. I'm going to talk about things that are a little easier to simulate. But you have a measurement actor, and you can see that it defines some basic stuff like, taking readings, starting a continuous reading loop, stopping the reading loop, and that's all great. And you point to a couple of child implementations. And, one is like an analog input force sensor. So you get some voltage or something, and then that translates to a force. And then the other is a playback actor where you've recorded some force sensor data in the past, and then you just want to play that file back to see what it looks like as it runs through your application, right? And that's nice because the parent defines most of it. And then really you just have maybe one override, like take reading core, like how are you getting to the data? Maybe there's some like, with hardware, you're doing some connection, closing, whatever. But essentially, the child's class contract with its parent is just, hey, how am I getting data from you? And I think that this is a really nice breakdown, right? This is a very good use of inheritance. Now, going to throw another wrench in, though. Let's say you're doing this application for a while, your end users are happy, and you're taking data, but then they're like, hey, you know what? Sometimes we run into problems. And they want to design for debug, right? So they point to, they want logging. You want logging. You want to see when the actor starts up, when it shuts down. You want to see when you start acquisition, stop acquisition, all that great stuff. And you're like, okay, great. Again, this is not my first rodeo. I've written a logger base class, and I'm going to point my force sensor or force measurement actor to the inherit from the logger. Who's done this before? Yeah, I've done it before. I've had this in the base parent. I still do it, but with a little twist. So you have CSV logging. Awesome. Again, can anyone predict the wrench, like the problem here?
Different formats.
Yeah, different formats. So this works great. You're pointing to log event. You have your CSV specific code. Awesome. And you're generating your logs. Users are happy. Then some random other user is like, you know what? I don't like CSV. I want JSON. I want XML. Some guys like, I want a live GUI of the log events. Don't give me a file. I want to see it as the application's running. And you're like, oh, great. There's completely different things, right? And what a lot of people do is they'll make a case structure with an enum, right? And so you're pointing this case structure, all these different options. Does anyone have an issue with doing it this way? Anyone predict what's wrong here? Norm?
Yeah.
Okay, yeah. So, all right. So I'd say that one issue is that your base class all of a sudden is relying on a lot of things. You might have a lot of stuff in your private data all of a sudden. You might have enqueuers going to like a GUI. You might have an SQLite library dependency. You have these log references that might not be used in every case, right? It's super overloaded. And what's wrong with overloading? Well, I'll get into that later, I guess. But it breaks encapsulation for sure, right? This is not ideal. So what are some of the drawbacks? Like I said, when a child class needs additional behavior, when you're changing more than one thing, basically, it's and you can't control those things through dynamic dispatch, then it's really tempting to just start overloading the parent class with things that all the different children might need. That's really tempting, right? And so you get a lot of unwanted dependencies. That's not good. And the other thing is that breakages in any one of those libraries suddenly breaks everything. Whereas if those were not statically linked, that would not necessarily be the case. You could load up those leaf classes, those concrete classes in their own project. They don't know what plugins are getting dragged in until runtime. But when it's all statically linked, all of a sudden your force sensor analog input driver, why is it depending on a CSV like library? Why is it depending on SQLite? That's not good. And then let's say Casey is in charge of the CSV logging. I'm in charge of the XML logging. And we both need to make changes at the same time to the parent class, to the same exact methods with all those case structures. That gets messy very quickly in source control, especially with LabVIEW. So like I said, inheritance fixed, so children can't choose between different implementations at runtime. If you wanted to switch what you were doing on the fly, that's not easy with this case. And it's hard to mix and match different features, different behaviors across different features. So how can composition fix this? Well, what you can do is instead of inheriting from some logger base class, you can composite the logger into your force sensor. You can composite the driver. And now you have all these different plugins that you can pick and choose from. All these different plugins that you can pick and choose from dynamically, right? You can mix and match freely, and the child classes of the behaviors. There's a CSV class, there's a JSON class, there's a LabVIEW class, and the file playback and the analog input don't depend on that at all. So you get the benefits of inheritance in the sense that the composed components can pick and choose their dynamic dispatch behaviors without being locked into a single inheritance tree. Any questions about that? All right. Okay, so I can do this two ways. I actually, I've been watching all the demos this conference, and they all kind of work out in the end. But I would say that most of them have hiccups. And so I'm like, I did pre-record a version just in case, but I'm not a coward, so I'm gonna do it live. Famous last words. Okay, so this would come back, that'll be good, great. Okay, Square Battle is running. I don't care about that. I'm gonna close Square Battle. And, okay, so this is an example of a composed version of exactly what I was talking about. So you have your force measurement actor. Can everyone see this, by the way? I made the virtual machine 150%. People in the back, does it look all right? Huh? I can zoom it if it's not enough. Yeah, all right, so. There. Yeah. Okay, there. So you have, I just learned how to use this 30 minutes ago, so I don't know, but. So you have your force measurement actor, and you can see that you have wrapper methods for the composed classes, the force sensor driver, and the logging. You can see you have cleanup driver, initialize driver, take reading, cleanup logger, initialize logger, log event. And over here in the private data, you can see you have your composed members, right? Great. And all I got to do, hopefully, is run the demo. And the options that are being loaded in dynamically, you can see here there's a GUI log, live GUI log. And then down here, there's a analog input force sensor. I don't have hardware, so you're just going to see a GUI pop up with a little analog input knob for me to turn to set the force. And if I run it, and I haven't screwed up, it should just go, right? So, beautiful. So, you can see I can change the force. It updates. You can see the live logger here, showing new events, which I guess is not live updated on the zoom in. Yeah. So you can see the feed going. And it all works, great. And if you want to change any behavior, you can just go ahead and be like, you know what? I don't want a live log. I want CSV. And instead of the analog input, I'm going to do the log playback. No. So now there's no window for the analog input. There's no window for the log view because the log is being live updated to file. CSV log, there it is. Oh, it's open already. All right, yeah, so you can see that's the current time according to my virtual machine, which is apparently still in California time. But I swear it's 10:22 a.m. current time according to the VM. So you know the log is being updated. And we're getting all that nice behavior, right? Awesome. So that's basically how composition works. And so people like composition, right? I love composition. I use it all the time. If I had an issue with composition, it would be that I hate writing these wrapper methods over and over again. This is doing nothing, right? And all I'm doing is I'm just unbundling and unbundling, calling the method I want and rebundling, and I have a wrapper around it. So when I want that code, I call it. You could, if you don't want to make a wrapper method, you could just unbundle and call the method and rebundle every time. And in that case, I think you're a psychopath. But you know, if you're calling that method multiple places, like in log event, for sure you're calling log event more than one place, right? So in this case, it's a very good idea to have a wrapper method for this instead of doing it, sprinkling it all over your code with the unbundles and bundles and accessor methods if you're using accessors, all that stuff. So I hate doing that. I hate that dredge work of composing a class in and then right-clicking, make a static dispatch method, and then like unbundling, rebundling, blah, blah, blah. I hate that. So at Zaya, we made a tool. If the VM would close so I can switch it. We're starting to work on moZart. And I think moZart makes it a lot easier. We have a couple things we're working on that we're hoping to make work pretty smoothly there. Okay. And I'm gonna switch to the pre-compose state on my VM. People like using VMs? How many people use VMs? All right, about half the room. That's good. The other half should look into it. It's like amazing. Except that my nice mouse, my like fancy mouse with all the programmable buttons and stuff don't work on the VM. That's like the one drawback. Okay, so what I'm going to do with moZart is I'm going to start with a force measurement actor that you can see that the data here is bare. There's no composed member classes yet. And so this doesn't do anything when I run it right now. And I'm going to use moZart to add in the force sensor driver and the logger behavior. And then the application should run just like in the first thing I showed you guys. If I did everything right, which is questionable. Okay, so launch moZart. And you can see here that I'm going to define the containing class. I'm going to define the member class. And I'm going to give a label to the member class that I want to add. And there's some other features here, but let's do this. Oh, by the way, because it's an actor, I have these options over here to add messages, but if it were not an actor, if it were just some random other class, then those options go away. So it's based on what the containing class is. But we are working with an actor in this case. It doesn't have to be, by the way. I know that sometimes people are intimidated by actors, but you could do this with I guess a DQMH state class or whatever you wanted to. Okay, so I'm defining this, but I don't want to call it force sensor driver base. I'm just going to call it force sensor driver. I want property node access for it so that I can load it at runtime, just like what I did in the initial demo. This is, let's see. So now I know that these are the three methods that are available. That's found out, like moZart automatically finds the public methods of that class and displays them for you to wrap. I'm going to wrap all three. And I'm going to change the names in a little bit. Like it initializes with just the exact same name of the API of your class, but cleanup and initialize is too general, right? Because I have multiple things going on. So I'm going to call this cleanup driver. And I'm going to call this initialize driver. And take reading is actually already a message in my actor. So I'm going to call this take reading core. because that's like the under the hood ability I want. I'm going to change the access scope of the methods to protected, just in case I go crazy and want to do inheritance again later. And then I'm going to compose, and hopefully it just adds it. Let me pull up the thing. Private data. There we go. All right, magic moment. There we go. You can see the force sensor driver got added to the data. All the methods are generated. So the scripting went through, it added force sensor driver. Over in the project window, you can see that the wrapper methods got added just as I named them. I'm going to go ahead and drag them into the force sensor folder. And then I'm going to do this little ritual, which I'd like to ask people, why is this necessary? Where after I move anything in a class, I right click and save on the class, because otherwise LabVIEW forgets where that virtual folder placement was. That happens to me all the time. I don't know why. I see people nodding their heads. So if anyone can tell me why that happens, that'd be great. All right, and then I'm going to go back to moZart again, and I'm going to add in the logger behavior this time. Same thing, I want to wrap all three. Go ahead and make them all protected again, so that children classes of force measurement can call them. Log, giving them unique names again. And I'm going to hit compose, and this should just work again. There. That's all great. Again, gonna drag these guys into the logging folder. Do my little hokey pokey ritual with the class. I went ahead, so there are these bookmarks here showing all the places I need to add the stuff. You can see, oh, go ahead.
I just had a question. I just had a question about how you're doing the composition. My natural instinct, instead of including some of those things as a class, would have been to just include them as an incur for the actor.
Yeah.
I don't know if my instincts were wrong, but I was just curious what your thoughts on that were.
I would say that the driver would probably, I'd compose in, and the logger I would probably have as, I've done it different ways. So I would probably have a logger actor that's like running independently and route the message to that actor through the message tree. But with Zaya, we actually have this thing called, we have a logger interface with different behaviors depending on what we want. Sometimes you're just running a little test application that's just that class. You don't necessarily want to spin up a separate log actor in that case, right? Sometimes you just want to say like, hey, in this case, just go ahead and log the files. Don't worry about performance, whatever. And so we have something called it's not called logger behavior, but you can imagine a logger behavior class interface where sometimes it's doing the write to file itself, and other times it is just saying, I'm going to push this to caller. And it just depends on what behavior you want. That's an example where you can kind of do it both ways with composition, because your decision on whether you're delegating the logging to something else or you're doing the logging in line in that VI your compose class decides that, right? Yeah. Any other questions?
This is another question about the design of composite classes.
Yeah.
So in your first example with communicating to a DMM, that's basically reinventing Visa, right? So one of the problems with Visa in my opinion, one of the problems with Visa is when the class was designed, the composite class of Ethernet or USB or serial or GPIB is the union of every property and every method of all the child classes.
Yeah.
And I don't. So basically everybody just always uses the parent class because it can do everything.
Right.
But it's harder to use because it exposes everything, even if it doesn't make sense. So in your world, for things like this, what is the right balance, or should it just be a parent class? What is the benefit of making it a composite class, and what do you include and not include?
So you're saying that because each device has specific needs with that interface, you'd rather just be like, okay, this device it's just its own thing. I don't need to composite in another communication interface. I just know this class needs to behave this way. Is that right?
Well, it's for example, because I'm always programming at the parent class, I see serial like baud rate settings and TCP IP address settings and GPIB address settings, and if I call the wrong thing, depending on what the implementation is, I will get an error.
Yep.
And so it makes it harder to write the kind of my code that is going to call it.
Right.
Because then I have to have case statements to, make sure, this is serial, therefore only call these methods on the composite class. Or set these properties on the composite class. I have to know things at my level, as opposed, it's like it hasn't really hidden everything inside of it.
For me, I would push a lot of that stuff into, make sure your exposed API is properly abstracted. I think that's hard. But like, if you have a configure method, like maybe you're loading in, before at runtime, you have a property node, you're loading in baud rate to that specific thing that needs baud rate. When it goes in as into the top level and goes down, it'll hit a configure method. And inside the configure method, that's where all the details go. That's where the case structures and all that stuff goes. I don't think you won't always get it perfect. Sometimes, but if you have a well-designed API for that composited class, I think you can avoid a lot of those situations.
I agree. In NI's case, they solved it with Max. Go configure it in Max, and then Visa write is all you need.
Good question. Thanks, Brian. Anything else? Okay, so I went ahead, and you can see that I had already dropped these methods onto the block diagrams before. They were question marks right before the composition happened. I probably should have shown that. But if I just change my project conditional symbol thing, then we will hopefully get a working project that does exactly what the last one did. So I'm going to change composition from false over to true. I'm going to run it. So, wait. All right, that was almost my mistake. I have to actually composite in the concrete versions of what I want. No. And once we do this, it should hopefully just work. I'm going to do this. This is the only good use of cleanup. Wow, it works exactly like before. So that's how moZart helps with that. And you can see that the behavior is the same. Like I can mess with the AI input. And then at runtime, I can define different behaviors if I want. So I can already see moZart being very useful for us in a lot of cases. I'm going to show another small demo, which is not fully functional, but we'll just show you the idea of doing it with an actor with messages. But before that, any questions?
So your scripted VIs have like a get reference and a write back reference.
The little green and red. Yeah.
And so I guess what I've always done is I've just used the in-place element structure to read the reference and write it back again. And so I guess my point is those sub-VIs would have to have a semaphore or something in there to protect them from race conditions, right?
Wait, why would they need a...
Well, if you had two parallel VIs that both tried to access that data at the same time, then you could have, two of them writing back.
I think you would have different copies of that composited class in each actor that's running.
Well, but if your one actor tried to access it in two places, maybe. I guess an instrument might not be a good example of that.
You're talking about one hardware reference?
Yeah, maybe hardware reference isn't the best example, but yeah. But for other objects, you might want to do that, right?
So you're basically saying if there's persistent references in that composited data that's shared across copies of that composited data, you might run into problems, like a shared resource. Is that what you're talking about?
Well, I think I'm saying in the same class, if you try to access that twice.
I see. So you're worried about the same class, not in this case where it's an actor. So not an actor, because an actor would execute one method at a time.
Yeah.
But some other state machine class where you might have parallel operations using the same method. I think if you're worried about that, you should make that method non-reentrant.
I think you'll say don't branch your class wire.
What?
Don't branch your class
Yeah,
wire.
don't branch your class wire. That's also a good point. If you have two class wires with state, and it's important that state not be duplicated, don't branch it. Yeah, that makes sense. Thanks, Dan. But
the point of my question though is that so the in-place element structure is supposed to be more efficient. I don't know if doing what you're doing there like makes a memory copy or anything like that. Have you seen that, or do you know?
I did not consider that case. This is how I've always done it. But there's people in this room who understand the compiler a lot better than I do. Anyone want to chime in and think if an in-place element structure for calling composited methods is better than just unbundling and bundling? Adam?
So the first thing that comes to mind is, I'm not 100% sure of this, but are you talking about using like an in-place element on the class object? Yeah, so if you have, that's sort of breaking down the encapsulation thing, because it's...
I think he's saying that instead of doing this with, instead of doing that with the read-write accessors, use the NES around the class inside its own. It's still in its own method.
Got it. Okay. Disregard my comment then.
Okay.
So again, everybody make sure you read the LabVIEW compiler under the hood page on ni.com at least once a year. Set a calendar reminder. I just did my reread a month ago. The compiler has some optimizations that look for patterns that look exactly like this, but imagine an unbundle and a bundle instead of an accessor and two sub-VIs. And when the compiler sees an unbundle and a bundle, the intermediate representation will pretend like you had an in-place element structure there. It can actually recognize those patterns. So my recommendation would be that, when you think about it, yes, explicitly use an in-place element structure, but even if you don't, sometimes the compiler can figure out that it can operate on those things in place and do it anyway when it compiles your code.
Okay. Good question, Jeff. Adam has another question, if there's another mic available for him up in the front.
Yeah, just a comment to that point, unrelated to the
in place.
Yeah, well, it's related to the in place, but one reason that I always use accessors or at least property nodes is for traceability. So it's like unbundling and bundling class data, whether it's with just the nodes or the in-place element structure. It's a lot. It's easier to find where data is being accessed if you're using accessors or property nodes compared to just bundling and unbundling class data.
Yeah, I have mixed feelings about it because I think Alan next to you has a question, Adam, if you want to hand that to him. Real quick on Adam's comment, I have mixed feelings about using accessor methods. I do agree it's easier to find, but if you want to change a data label in your private data, it's like pretty annoying to like have to go and fix your accessor methods. In this case with the compose classes, I think you can't get around it. You kind of need an accessor method if you're going to be composing things in at runtime. But in general cases, I kind of have mixed feelings about accessor methods. Sometimes I use them, sometimes I don't. Alan.
Were you talking about finding places where you're
unbundling?
Yeah.
So actually, I want to check and make sure I understood what he was saying before I chimed in. If you're trying to find places where your data is, where a class attribute is being used, there is a tool that I cannot remember the name of at the moment, but I think it's like find all uses.
Oh.
And you install it. It shows up on your on one of your menus, and you just find you right click on the it's a right click menu item. You right click on the attribute in the class attributes and it in the private control, and it will list every single place that it is being bundled or unbundled, whether it's in a or sometimes you crash.
Can someone tell me when that happened? All I was doing was closing windows in Window Manager and just shut down.
If I ain't crashing LabVIEW, I ain't working. And it's a really handy tool. I highly recommend tracking it down and using it. I can't remember what it's called at the moment.
I'll put it in Discord when I remember what it is.
I think Brian has a question.
We got a question after.
Okay. So this, and then Brian after.
I was going to ask Darren, does the compiler recognize it when you have it wrapped into accessors, or does it have to be explicitly unbundle and rebundle?
I think it does recognize the accessors.
Okay, that would be good because children.
They're marked as inline, so it's just a CDF bundle. Especially if you remove your error case records from your accessors, which you should all do.
Yeah, that's good because a child can't just, well, maybe it does. Does child have unbundle the parent information? Or do you need an accessor for that, right?
Well, it's hard to say.
Okay, thanks.
Okay, real quick, oh, sorry, Brian.
So maybe this helps answer that question. So the thing that Darren talked about, its official name is called the magic pattern of, an unbundle followed by a bundle. And then when we added the waveform data type, we expanded the magic patterns that we looked for because we were trying to make it efficient. So the reason we added the in-place element structure and the reason I recommend using it often is it's declaring your intent to the LabVIEW compiler about this is what I'm unbundling and it's supposed to go with this thing over here that is bundling it back again. And so it was basically so that we didn't have to continue to add smarts to trying to detect the magic pattern everywhere.
Right.
But all that logic still exists. It's just like I like the idea of declaring my intent to the compiler of what I want to be in place. And so that's why I recommend using it.
Okay, thanks, Brian. We've got 6-7 minutes left. I'm going to go ahead and show the functionality to create messages really quick. So same thing with moZart. You can set the access scope of the messages. So I'm going to go ahead and make one private. I think it should also prevent me from changing. I'm not allowed to change the access scope of the method because it knows it has to be public in order to be wrapped into a message. So if I run this, it should add an actuator interface driver to an actuator base actor. This is a use case I see myself using it a lot because often we will wrap an instrument driver into an actor, and being able to do it this way, I think will save us a lot of time if the script works. All right, so claims is complete, which, these already existed because I ran this before. So that's my hiccup. But I promise it works. You can see the methods scripted, but they were already existing. So I don't think I have time to reset the VM and do that again. So I won't. Instead, I will turn it over. Any questions? If there's no questions, then I could reset and do it again. I discard this.
I just put the link to LabVIEW Class-ical Final uses in the Discord for this presentation.
Awesome, thank you. I'm going to skip that, but you can show you can do messages with moZart. Obviously, not all the it works on the happy path. That's why it's not released for community use. And doing all the unhappy paths is going to take a bit of work. Benefits of composition. I'll just blaze through this really quick. You get loose coupling between different classes and behaviors. So, it's not present. There we go. Loose coupling, so you can load drivers in a runtime. You're not overloading because now the specific things you want to do are in their own separate classes. Children can choose between many implementations through dependency injection. You can mix and match behaviors, bug fixes, all that source control stuff encapsulated. Awesome. If you're interested, we are looking for alpha testers to provide feedback. You can email me. You can hit me up on LinkedIn. We have a Zaya blog. We have a Zaya Discord. And we can go ahead and drop those links in the GDevCon Discord for this presentation. Questions? Everyone knows composition's better, right? All right, I'm just gonna run this for no particular reason while I wait and see if there are any other questions. Anything else? Alan.
So after you've started small and you're using a couple of classes in your application, this is the sort of stuff you start doing.
Yeah. There was a question in Alan's presentation about state pattern. And someone asked about how do you handle changing multiple options with state pattern. What we usually do is we composite the state in to our class. And if there's more than one thing controlling what's going on, then you could have multiple classes and they're deciding what gets dynamic dispatched into. We kind of like that paradigm a little bit. It does give you a little more flexibility. We named I don't know if you guys can see, everyone can see, but there's James Kirk in the corner, pew-pewing the Klingon warships. The insightful class was called, the insightful team, square team was called Kobayashi Maru. So that was our little reference. This is it fighting the non-insightful class. So they're the same, except one inherits from the other. And actually, I should have used composition in this case because what I would have wanted to do is be able to kind of use state pattern to swap behaviors. So sometimes I want the squares to be defensive. Sometimes I want them to be aggressive, And my initial thought when I was tooling around with it was I would just use state pattern and swap in a different square class depending on what I wanted to do. I have 2 minutes. Okay. And so I couldn't do that because I don't have access to everything that I need to transfer data from my old square to my new square. Because some of the square parent data is just private. I can't mess with the square engine classes. But if I'd used composition, then I could have composited in a square behavior, what I wanted to do, aggressive or not aggressive, and swapped it around. So that's like a very good example of where I should have used composition, but I didn't know that going in. So you ended up with this code that I wrote in a fever dream while super jet lagged from being from Thailand. All right, thanks, Jess.
A special thanks goes out to Kevin Chirey, Quentin Q. Aldridge, Mark Balla, and Jeff DeBoer for their help in filming. And of course, this GDevCon NA 2023 wouldn't be possible without all of our sponsors. Thanks.